Okay, thanks for the request to go through this question. It was split into two parts. One was asking you to find the differential of this function, and the second part was to find the equation of the normal to this function here. Right, so we can see there's an equation that's formed above the variable x and the variable y, and that should make us think really in the way that it's been given to us and the fact that we're asked to find the differential of it, that it's probably going to be a situation, especially since we've got y's in two different powers and in two different terms here, that the best way to approach this problem would be to differentiate implicitly, and you're right if you decide to do that too. So if we differentiate both sides here with respect to x, what are we going to get? Well, we can differentiate the x squared and get 2x, differentiate our 2y squared and get plus 4y dy by dx. Just remembering that rule that whenever we differentiate a function in y, we treat it as if it was an x, but remember that dy by dx at the end of it. That's the general rule. Minus 1 plus 4 dy by dx, and that's equal to differential of a constant, so that's just 0. Then we need to factorise this. So if we collect our dy by dx terms here, we'd get 4y plus 4. And if we chose in the same step to get rid of any of the terms which didn't have a dy by dx as a factor, we could bring this 1 onto this side and this 2x onto the other side by adding 1 and subtracting 2x from both sides, and we'd get 1 minus 2x. Now of course all we need to do is divide by 4y plus 4 to get dy by dx as the subject. And we could factorise out 4 from this as well. So this, I'm going to show that problem, so that allows us to show our answer now. The second part of this question was asking us to find the equation of the normal to this curve. Now we don't know really what this curve looks like, but let's say it looks like this. A tangent to this curve at the point we were given, which was 1, negative 3. So if this was the point 1, negative 3 on that curve, a tangent would of course look something like that. And it would have the same gradient but as the function, so I could just substitute my x and y coordinate for that. The normal would be perpendicular to this point. And so the gradient, if the gradient of the tangent was m, then the gradient of the normal would be the negative reciprocal of that m value, so minus 1 over m. So if we find the gradient of the tangent to begin with, we can substitute in our coordinates 1, negative 3 and get that our dy by dx is equal to 1 minus 2 times 1 over 4 times by negative 3 plus 1. And our numerator becomes negative 1, our denominator becomes negative 8. So the gradient of this tangent would be an eighth, and so the gradient of the normal is going to be minus 1 over an eighth, so negative 8. All we need to do now that we know the gradient of this straight line and we know a point on this straight line is substitute all that we know into y minus y1 is equal to m x minus x1, and to rearrange into a nicer form. So y minus negative 3 is going to be negative 8 times by x minus 1. And if we rearrange this, we get negative 8x here, plus 8 minus 3 would give us negative 8x plus 5, or 5 minus 8x. And that's the answer to that problem there.